Hi everyone, in Algebra 3 today we're going to be going over questions on lesson 74, starting on number 1. So number 1, there are 8 identical red ones, 4 identical blue ones. How many distinguishable arrangements were possible? So it's going to be n factorial divided by the number that are like factorial. There's a total of 12 ones, so that'll be 12 factorial over the 8 factorial and 4 factorial. So you could do this whole thing in the calculator if you wanted to. So it'd be 12 factorial divided by 8 factorial times 4 factorial equals, and that's going to be equal to 495. That was all done in my calculator. So it uses the second 3 button if you wanted to know that. Now for number 2, I have a rod is chopped into 3 pieces. The first piece is 3 times the length of the second, and the second is 3 times as long as the third. So basically what we want to do is we want to put these all in terms of the third piece. So that means the first piece is going to be 3 times the third, which is 90. And the last piece, the third piece, is just going to be t. So what fractional part, it's going to be t over the length of the entire rod, which would be the first piece plus the second piece plus the third piece. And that would simplify to t over 13t, and therefore equal to 1 over 13. And that would be number 2. Now looking at number 3, so you should notice that these are a lot of just concept review problems. They just want you to use your brain. It says a piece of cloth y yards long had f feet cut from one end and inches cut from the other end. What is the length in inches of the piece remaining? So it's going to be y yards minus f feet, and then minus n inches, but they want this to all be in inches, so I actually need to convert each of these into inches. So I'm going to start by converting this into the feet, so that would be 3 feet 1 yard, and then 12 inches 1 foot. That's our starting piece. Then the f feet would be 12 inches 1 foot. Feet would cancel, yards, feet. So that means I'm starting with 36y inches minus 12f inches minus n inches. So my result should be 36y minus 12f minus n. That would be my resulting cloth, because I started with 36y inches, and I subtracted 12f inches, and then I subtracted the n inches. That's number 3. Now looking at number 4, it says Sam received 2.5 times his regular hourly wage for working on Saturday. On one Saturday, he worked 2.5 hours and was paid 40.24. What was his regular hourly wage? So I'm going to start by just dividing this 40.24 by the 2.5 hours, because that's going to tell me how much he made per hour. So it's going to be 40.24 divided by 2.5 hours. So he made 16.096 per hour. And this was 2.5 times his regular wage equals how much he made on weekends. So 2.5 times his regular wage equals 16.096. And that means that 16.096 divided by 2.5 tells me that he normally made $6. His regular wage is going to be $6.44. So it doesn't come out evenly, but that's going to be his regular wage. Now looking at number 5, so it says Eleanor earned E dollars every month and spent P dollars. What fractional part of her income did she save? So if she earned E dollars but took away P dollars, that would be E minus P. And then that would be over how much she made. So that would be E minus P over E. This is how much she saved over how much she earned. Saved over earned. And that's it. Now looking at number 6, it's going to be similar. So it says a storekeeper sold N items for a total of D dollars and made a profit of P dollars. So how much did he pay? Well, if you subtract the amount amount was paid minus the profit, that means he started with D dollars minus the profit would be how much he paid for it, divided by the number of items. So this would be how much he paid for the item divided by the number of items. So again, concept review problems, just some of them are really easy and you just have to think them through. And that's what most of those problems are meant to do. So number 7, we have a horse galloped N miles at P miles per hour and then trotted M miles at K miles per hour. What was his average speed for the entire trip? So what we're going to do here for number 7 is we have distance is M, rate is P. So that means his time is going to be M over P. Second one is going to be distance is M, rate is K. So time is going to be M over K. And the reason we had to do that is because the overall rate is equal to the overall distance divided by the overall time. So the overall distance on this one is going to be M plus M. The overall time is going to be M over P plus M over K. So now you get 2M over MK plus MP over PK. You're going to multiply by the reciprocal, so that would be 2MPK over MK plus MP. But you should recognize that there's an M in each of those terms that could cancel. So your answer is going to be PK over K plus P. So you have to solve for the times of both of those before you actually input it into your overall equation. Now looking at number 10, we have a 12-sided regular polygon is inscribed in a circle whose radius is 10. Find the area of the polygon. So for number 10, what I'm going to do first is I'm just going to draw one of the triangles, of the isosceles triangles that would end up inside. When the circle is drawn on the outside, the radius would be the slant, which is 10. And what I'm trying to do is I'm trying to find the area of just one of the triangles. So this would be my base. This is my height. So I need to solve for the angle. And I'm going to exaggerate it over here. And the way you do that is you take 360 and you divide it by how many right triangles there are, which is always double the number of sides. So this would be 24. And we get our angle of 50 degrees. Now I'm going to use cosine to solve for the height. and sine to solve for the base. So now my height is going to be equal to 10 times 15 cosine equals, so 9.66. My base is going to be 10 times 15 sine equals, so 2.59. Now to find the area of the whole polygon, I'm going to do it based off of the number of right triangles, which again I said is double the amount of sides, so 24 times 1/2 base times height. So 24 times 2.59 times 9.66 divided by 2 gives me an area of 300.23 centimeters squared. So really I didn't draw out the whole thing. I just separated into the isosceles triangles to actually solve. Now looking at number 11, also from the same lesson, the length of a side of a 6-sided regular polygon is 4 centimeters. What is the radius of the circle that can be circumscribed about the polygon? Okay, so what we're gonna do is I know that it's gonna be my triangle. The length of the side is 4. So when I split this, I'm trying to find the radius, because that would be the circle that can be circumscribed, so around the outside of it, like that. So if I split this into 2 right triangles, the base would be 2 now. I need to find the angle, so I'm going to do 360 divided by 12, because again, it's 12 right triangles, which should give me 30. And now what we're going to do is we are going to solve for the radius, so we're going to use sine, so that would be sine of 30 equals opposite over hypotenuse, which is r. So r is going to be equal to 2 divided by sine of 30. And that would give you the radius is equal to 4. So this one did not take as much work as some of the other ones. So circumscribed means it goes around the outside of the circle, and then inscribed would be on the inside of the circle. Now looking at number 12, this isn't a new problem, but it's something that we did early on, probably in first 10 lessons. So 14-sided regular polygons are similar. Side of the larger is 1.5 times this corresponding side of the smaller. What is the ratio of the area of the larger to the area of the smaller? So area of the larger to the area of the smaller is equal to the side ratio squared. So it says 3.5 times as long. So, sorry, 1.5 times as long. So there'd be 3 halves to 1. And I would just have to square that. And that would simplify to 9/4. So you take the side ratio, which is 1.5 to 1, and then you just square that. Now moving on to number 13, which we are going to use the law of sines for. So what I need to do is I'm going to solve for this angle right here, even though it does not ask me to. I'm going to say that A is going to be equal to 180 minus 30 minus 15. So A is going to be equal to 135. And remember, the side opposite the angle constitutes a pair. So that means for number 13, I'm going to have a over the sine of 135 equals 20 over the sine of 30 equals b over the sine of 15. I'm going to start by just cross multiplying the first two. So that would be a times sine of 30 equals 20 times sine of 135. And you're going to divide both sides by sine of 30. So 20 times 135 sine divided by 30 sine. And that would give me A is equal to 28.28. And then I need to solve for B by looking at the last two. So that would be B times sine of 30 equals 20 times sine of 15. Divide both sides by sine of 30. So 20 times 15 sine equals, divided by 30 sine equals, you get B is equal to 10.35. Now moving on to number 14. So the first thing that we have to do is we have to put this into standard form, meaning that we're going to divide everything by 400. So that would be 25x squared over 400 plus 16y squared over 400 equals 400 over 400. That's going to simplify to x squared over 16 plus y squared over 25 equals 1. All you have to do is take the square root of the denominator to find out the distance away from the origin. So on each axis, so it's going to be 4 away on the x-axis, 5 away on the y-axis. And this shouldn't look like a circle, but mine's kind of going to because my lines are not proportional enough. But it should be 5 on this axis and then 4 on this axis. And lastly, we're going to look at number 15. Which says the scores on the standardized test are normally distributed with a mean of 100 and a standard deviation of 8. What is the percentage of scores that are greater than 120? So number 15, if I draw the normal distribution, it looks like this. The mean is 100. We want to find out what percentage is going to come above 120. So I want to calculate the z-score, and it's always score minus the mean divided by the standard deviation. So 120 minus 100 divided by 8 gives me 2.5. Now I'm going to go to my standard normal table that's in the back of my answer key. And I look up positive 2.5. So that would be down to positive 2 over to 0.5, which is 99.38%. 99.38%. So that means that the percentage that falls below this value would be 99.38%. But we want to find the percentage that's above. So you do 100 minus 99.38, which gives us 0.62%. And that concludes your questions from lesson 74. I hope you guys all have a great day. Bye.